Welcome to Study Loop.
Hi there. So for this problem, we need to find the heat absorbed of block of 1.22 kilograms of copper whose temperature is increased reversibly from an initial value of 25 Celsius degrees to a final value of 105 Celsius degrees. So for part A, we need to find the heat absorbed. Now, we want to find the heat that is absorbed. So for that, we use the following equation. That is the mass times the specific heat times the change in temperature. So from there, we will find that for copper, well, the mass is 1.22 kilograms, and the specific heat is for copper is equal to 387 joules per mole per Kelvin. And this times the change in temperature, we know that the final temperature is 105 Celsius degrees, and the final temperature is, well, the initial temperature is 25 Celsius degrees. So from there, we obtain that the heat is equal to 3.77 times 10 to the 4 joules. So that's the solution for part A of this problem. And for part B, now for part B of this problem, we need to find the change in entropy. So we know that the change in entropy is the integral from the initial temperature to the final temperature of the differential in heat over the temperature. So we know that the differential in heat can be written as the mass times the specific heat times the differential in temperature over the temperature. So from there, we can take out what is constant in here. So that is the mass times the specific heat. So that is the differential in temperature over the temperature. So we know that the integral of 1 over the temperature is the Neperian logarithm. So after evaluating that in the final and initial temperature, we will have that is the Neperian logarithm of the final temperature over the initial temperature. So in here, we just simply substitute all of those values in there. So we have the mass, that is 1.22 kilograms, times the specific heat for copper, which is 387 joules per mole per Kelvin, and the Neperian logarithm of 378 Kelvin. That's because we convert the final temperature from Celsius degrees by just adding 273. So we obtain that from Kelvin, and to this we also add 273. And for that we obtain a value of the initial temperature of 298 Kelvin. So from this we obtain a change in the entropy of 112 joules per Kelvin. So that's the solution for this problem. Thank you.